Hello, Ma'am over here, and welcome to another module in Earth Science. In this module, we will be talking about the geologic time scale. We only have one learning objective for this module, and that is to describe the history of the Earth through geologic time. So you may be thinking, wait, didn't we discuss this before? Yes, sort of. We did discuss the formation of the Earth in detail in the first quarter. However, we did not discuss what had happened after the formation of our planet and before human beings existed. So we will be covering what had happened in that space of time. So after the formation of our planet and before the human beings, what are the organisms and the major events that had happened in between. So this module will be like a journey through time because lots of interesting things that we will be discussing. Okay, so speaking of time, time is a human construct and it is something quite hard to grasp, especially if we are talking about 4.6 billion years worth of time. So our planet has been formed 4.6 billion years ago, and human beings have only existed for 100,000 years or more. So if it's quite hard to understand how much time has passed before us. So to give you a perspective, this is a proportional chart. So we will lay out the 4.6 billion years in a 24-hour clock format to give you a perspective. So take note in this chart, according to this, proportionally, human beings have only existed for less than 2 minutes. In comparison to what had happened before us, we are a very young species. Okay, so there are notable events that had happened before us. For example, after the formation of our planet, we have the meteorite bombardment. So during this time, nothing is really on our planet except the planet itself. So you have a planet without an ozone layer, and the surface of our planet is molten. But as soon as our surface starts to cool, you have life already. So bacteria started to occupy the surface of our planet. And we know this because we have dated fossils which come from around that time. So if you make an estimate of how much time it requires to make much of those fossils, then you can have an estimate of when life began. So since bacteria and photosynthetic bacteria occupied our planet, our atmosphere drastically changed after several years. There, you have an evidence based on the abundant banded iron formations. So, since oxygen or free oxygen started to occupy or increase in our atmosphere, it reacted with the iron present in our rocks. So you have these layers of rocks which are reddish because oxygen started to react with or bind with the iron. So you will see that as our planet as our planet ages, there is an increase in the oxygen and iron interaction in our rocks because of the bacteria in our planet. Okay, so stuff became more complex because you have single-celled algae, which is very more efficient in photosynthesis. So they also started to become complex because you have sexual reproduction happening at 6 p.m. So because of sexual reproduction, you have more cases of mutations and changes in the chromosomes, and things started to get interesting. So around 828, you have seaweed, which are multi-celled organisms already, but still occupying the oceans. Then you have your animals, which are the jellyfish at 848, the trilobites at 904. So trilobites are more complex because they have a hard covering protecting their own bodies. Then at 952, life started to migrate to land. So you have your land plants, which became very successful, proved by the coal swamps. So large land plants occupying a large amount of space. At 1024, dinosaurs started to roam the land. At 1056, mammals at 1139. Oh, by the way, dinosaurs and mammals actually existed at the same time, but mammals dominated the land after the dinosaurs. Then the humans, of course, at 1158. So, a lot of things that have happened in a 24-hour clock. Okay. But of course, geologists don't use a 24-hour clock in order to organize what had happened in the geologic time. So for the geologists and paleobiologists, we use something called the geologic time scale. So it's a hierarchical division of time. It's still a human construct. That's why we are always changing it, updating it, and improving it. But so far, this is what we're working with. The geologic time scale aims to divide the time that has passed before us in several divisions. So you have eons, era, period, epoch, and age. So of course, eon is the biggest of all, followed by era. So eons are made up of eras are made up of periods, and the epochs are made up of ages. So the eon, if you want to understand it further, I can it's sort of like a clock as well. So the seconds is the smallest, followed by the minutes, followed by the hours, followed by days, weeks, months, years. So it's like that, but in this case in a much larger scale. So age is the smallest, followed by epoch, period, era, and eons. Okay, so I hope that was clear for you. Okay, so let's talk about the biggest of all the geologic time scales, and that is the eon. So the eons are the largest intervals of the time scale, each over 500 million years long, and they mark major changes in the Earth system. So when we're talking about eons, take note that it's not like the hours or the minutes that we are talking about, because for geologic time scale, we are organizing them based on major events. So if there are certain events that have changed the environment and the type of organisms that roam the land, we change the geologic time scale. So for the eons, they have different lengths. 500 million years is the minimum length, or the shortest length so far. But as I said, they vary in length and are marked by major events. So there have only been 3 eons in our history. So for the Archean, the first eon is the Archean. So it used to be called the Hadean eon, from the Greek god of the underworld, Hades, and is used to represent the earliest part of Earth's history from its initial molten state until the first rocks are formed. So during the Archean eon, our planet nothing really existed on our planet except the molten surface. So during this time, the heavy bombardment has happened because we don't have an ozone layer, and basically the planet was still in the last parts of its formation, but the planet started to cool down. When the planet has completely cooled down, that's a major change in our planet, so we changed the eon. So from the Archean, we changed to the Proterozoic eon. So during the Proterozoic eon, life have proliferated. So means earlier life. Oxygen began to accumulate in the atmosphere in greater quantities than before, and life evolved beyond primitive bacteria. So for the Proterozoic, this is marked by the increase in oxygen because the planet itself cooled down. It allowed bacteria to multiply on the surface of the planet, and then you have your cyanobacteria. So you have your normal bacteria, which it's not really photosynthetic, but once photosynthetic bacteria, cyanobacteria, and algae um, rose into life, then oxygen accumulated in our atmosphere. Then, after the Proterozoic eon, you have the Phanerozoic eon. So this means life revealed. So marks the break between older rocks in which fossils are rare and younger rocks that contain abundant fossils formed from organisms with shells and hard skeletons. So during the Archean and the Proterozoic, life was pretty much simple. You have bacteria and algae, cyanobacteria. That's great and all, but so much could happen. And Phanerozoic eon, things started to get exciting because you have species, multicellular organisms, which have different forms and different shells even. So during the Phanerozoic eon, organisms started to use shells. So you have this layer, if we will compare the rock layers between the eons, the Archean and the Proterozoic have stromatolites, which are bacteria, rocks formed by bacteria, but by the Phanerozoic, you will see rocks which had combination of shells and hard skeletons. So life really became complex. Okay, so let's compare the length of time between the three eons. So Archean over here, Proterozoic in the middle, and the Phanerozoic on top. So you will see specifically that Phanerozoic is only 542 million years long. The Proterozoic in comparison and the Archean are way longer. So this time scale, by the way, is million years ago. So if we're saying 4,600 million years ago, that's 4.6 billion years. Okay, but just to simplify, let's stick to 4,600 million years ago. So this is the formation of our planet. In the Archean, eon, you already have bacteria existing in our planet already. So it's not really empty, shall we say, because bacteria is already starting in the Archean, but our planet has changed in terms of oxygen by the Proterozoic. So by 2,500 million years ago, or 2.5 billion years ago, oxygen started to accumulate, and then organisms become multi-celled. So from being single-celled bacteria, you have multi-celled organisms. And by the Phanerozoic, fossils became common in rocks because of their complex structures that can be preserved. So currently, you will see that the present day is included in the Phanerozoic. So we, human beings, are living in the Phanerozoic eon. Okay, this is showing you what are those fossils here. So we did see bacteria, fossilized bacteria, fossils of bacteria from the Archean, and they come in the form of stromatolites. So stromatolites are structures like this. This is stromatolites from the coast of Australia, by the way. So these stromatolites are rocks formed by bacteria. So as they live in rock layers, they sort of create continuous layers. So, for example, this is a cross-section of a stromatolite. These rock layers, each one has been made by a layer of bacteria. So, as more and more bacteria lives on the surface of the stromatolite, it hardens, and then they just continue living, and the rocks continue to grow, and they leave this mark on our rocky shores. So there, the proof that bacteria lived in the Archean eon. If you date this would go back as much as the Archean eon. Okay, so we'll stop here for now, since we have already described the eons, and then we'll go into detail with the Phanerozoic eon in the next video.